So let's go into all of that. Let's start with the subject of the food matrix, which is a term I hadn't actually heard before until today. What is the food matrix, and why do I need to know about that?
So the food matrix, simply put, is the structure of food. And it's really important because we know that food is so much more than just the nutrients and chemicals it contains. So we know that food contains nutrients that people are very familiar with, like protein, fat, fibre, carbohydrate. We know that food also contains thousands of other chemicals. Many of these we call bioactives that you'll have heard of, like polyphenols, vitamins, minerals, etc. But they're all encapsulated within the structure of a food. So think of an apple versus apple puree versus apple juice. They're all coming from the same food, but they have a different structure. And the reason it's important is because we know that food structure modulates the healthfulness of the chemicals and nutrients within the food. And it's really, really relevant now. It's really relevant now because our food landscape has changed almost unrecognisably to 50, 100, 200 years ago. We're now eating a lot of food where the food matrix, the structure of the food has changed. And this is because we use multiple different processing techniques.
So, in simple terms, if I were to zoom in on a piece of food on a microscope, the way that the molecule of the food is put together is now different to what it used to be, and that's having an impact on my health?
So in simple terms, it's that we are changing often through processing the structure of the food. Now, by processing, it could be our own processing. When we chew a food, we change the structure. Take a nut, for example, you have a whole nut, you chew it, you break up the nut, it goes into your gastrointestinal tract, it's broken down further. We also change it using manual industrial techniques as well. So we use techniques like grinding, or we might use pasteurization for dairy, or, extrusion for some carbohydrate-rich foods. We use all of these different techniques that also change the food matrix.
For better or for worse?
It's a double-edged sword.
Right.
And I think this is what we need to remember, that everyone's demonising at the moment. Ultra-processed food, it's killing the nation. 60% of our energy is coming from ultra-processed food. Yes, we are eating too much unhealthy food, much of which has been heavily processed, but processing can also be used to our benefit. And we have to think, why do we even process food in the first place? Well, we process it to make it edible. I don't want to go and eat a rice grain that's not been cooked. We make it safe. I want to drink pasteurised milk because I know it's safer. We want to make it stable. I think how long a can last, and frozen vegetables versus fresh. So you're saving food waste. We want to make it taste good, and we want to make it convenient. So there's all of these different reasons that we use food processing. But when we think about the healthfulness of a food, we need to think about it in terms of the processing techniques that have been used, as well as the nutrient composition. We can't look at them in isolation, in my opinion. And this is what I've done a lot of research looking into.
And what is processing gone bad?
I think processing gone bad is when you've changed the nutrient profile of a food such that it is unhealthy. So in simple terms, it's too much saturated fat, too much salt, too little fibre, too little bioactives like polyphenols, a food that is very energy dense. So you eat it really, really quickly. So you're eating too many calories. You're eating it before your hunger signals have got to your brain to say, whoa, Stephen, you've had enough. And there's great research that has been looking at how processing can affect your eating rate, the energy density of food, the nutrient profile of a food. And that's where it can go wrong. But where it can go right is you can improve all of those things that I've said, the stability, the safety of the food. You can also increase what we call bioaccessibility, so the availability of some of the nutrients within a food as well.
Okay, so I've got some snacks over in the corner of the room here, which I guess have been processed differently to have a different impact on me as the consumer. Gosh, these look delicious.
Oh, I hope they're salt and vinegar Pringles.
You're going to eat them? Look at this. Oh my gosh. So I've got some mixed nuts here.
Yep.
And I've got some cookies, some little pieces of chocolate, and some crisps. So you were talking about this processing something so that I eat it faster and that it doesn't like sort of satiate me or make me feel hungry. Crisps. We're a nation of crisp lovers. When you were saying that about something that makes you eat fast and not realize that you've even eaten it all, crisps were the first thing that came to mind for me.
I love a crisp.
You love a crisp. We all love a crisp.
So I think all of these first three foods, the crisps, the chocolate, the cookies, you know, if compared to what would be a healthy food, they've all got less fibre. They've all got, well, certainly the chocolate and the cookie has got more sugar. They won't have all of the wonderful bioactives in them. And then with the crisps, depending on the type of crisp, it's probably quite high in salt. But the chances are with those three is that they are quite energy dense, so they have quite a lot of calories per gram, which is partly because of the processing techniques. Yet if you take a whole food like a nut, now they're actually very energy dense. So they're very high in fat, they're high in calories. But actually, because they're in their original food matrix, how your body handles them is quite different to if, for example, they had been processed.
You mentioned something about my brain takes a little while to figure out that I've started eating.
Yep.
So if I started smashing these crisps down now,
Yep.
how long would it take my brain to realize that I'd started eating to sort of catch up and make me feel hungry?
Yeah, so there's lots of different mechanisms that impact how full we feel, how hungry we feel related to a food. There's different hormones that are released from different areas of our gut, for example, that feedback signals to say either you're full or you're hungry. On average, I would say it takes about 10 to 20 minutes for the fullness to really properly kick in. Now, you could easily have got through those. Well, I could easily have got through all of these in under that 20 minutes.
I wasn't aware that there was a delay, but it does make sense because there's certain foods that I used to eat, like Pringles and snacks and crisps and things like that, where I feel like I could eat 2 tubes of the thing before my body even realized what was going on. And are they in some way designed to encourage that speed of eating? And
so there are many people who will say the food industry has specifically designed these to make them, firstly, what we call hyperpalatable. So to have the right mix of fat, sugar, carbohydrate, etc., to make them really tasty, and in this case, salt as well. I don't think the food industry is out there to get us. I think that what the food industry were doing 50 years ago versus what they're doing now is quite different. But some people will say I'm very naive. I do believe the food industry ultimately want to produce food that's safe but also healthy for us. That's probably an unpopular opinion, but based on my interactions with the food industry, I believe that. However, I do believe that these crisps are there, have been made to be flavoursome, to be palatable to you, so that you do enjoy them. Now, whether that's that you then go and overeat them, I think is, yes, a byproduct of that. Now, it doesn't take 20 minutes for all of the fullness signals to kick in, because as soon as you start chewing something, you start to release different hormones, and different sensory characteristics of the food will also trigger some sort of fullness. But what we do know is that you have more of these fullness receptors saying, hey, you're full, lower down in your gastrointestinal tract. And so if you can get food to the lower gastrointestinal tract, that's when it says, hey, Stephen, you're full now. And these heavily processed snacks that you've got here would be typically absorbed higher up the gastrointestinal tract, because kind of the hard work's been done. And yet when you've got something like a whole grain or a nut, typically that would be absorbed lower down the gastrointestinal tract, where you've got more of these fullness signals, so giving you that greater feeling of fullness.
My girlfriend has said to me for many, many a year that I need to eat slower.
Yep.
And I thought it was like a spiritual thing that she's into, to do with like giving the food gratitude, et cetera, But upon reading your work and having this conversation today, now I'm starting to believe that she was right all along, unsurprisingly once again, and that there is a scientific basis for slowing down how fast I eat.
Absolutely. We now know that eating rate's important. There's some fantastic work that's being done by a Professor Kieran Ford, who's dedicated many years into researching this and looking at how changing the structure and texture of a food can modulate your eating rate, and how also your eating rate can modulate how you metabolize the food and how many calories you go on to eat. And so it's a great example. You know, I talked about all of these different pieces of the puzzle. That's one of those pieces. So when we talk about how you eat, changing your eating rate, so how quickly you have your breakfast, your lunch, or dinner, or any of these snacks, will also, without you consciously thinking about it, change how many calories you eat, might change how quickly you metabolize the food as well.
What's the sort of knock-on effects there?
So the research that's been done by Kieran Ford shows that on average, if you change the speed in which you eat your food by about 20%, you reduce your calorie intake by about 15%. And that's due to where you're releasing your hunger hormones, how many fullness hormones you're releasing, etc. So it's a really simple strategy. And we see this play out as well, even in our own evidence, when we look in our Zoe Predict studies at fast eaters versus slow eaters. We see that once we adjust for lots of other confounders, there's a difference of 120 calories between what fast eaters have over a day versus slow eaters, with the fast eaters eating more calories compared to slow eaters. And there's even been clinical trials where they get groups of individuals and say, okay, slow down the rate at which you eat your food over the next, 3, 4, 5 weeks. They have another group, they say, just eat at your normal rate. Those people who are intentionally slowing down the rate at which they eat their food lose more weight than those people who continue to eat at their normal rate.